Be ready to lock it in today. If you go under Unit 1 on our page, on our classroom page, please open up the review topics. Quiz 1 review topics, please. Open that up for me so you guys don't have to write anything down. I have it there for you. And also get your packet open, please. Get your packet open. Today's review. They're all up there, 27, 28, 29, all hanging up. Okay, have your packets too. Have your packets open to the review. All right, before we start any review, anybody want to ask any questions from adding and subtracting your unlike denominators from yesterday? The suggested problems there that you were trying out. Again, look, we have our fun in here too, but also I watched like one or two of you yesterday when I gave you time not to do anything. When I gave you time to do these problems, all right? You just stared off and didn't do it. Hey, that's your call, but it ain't going to be pretty in here. All right, so you might want to get out of here. Go, Will. What do you got?
I have a question from like the day 5 class.
Okay, whatever you got, I'll take. It's all review for tomorrow, so just let me pull it up.
It was number 6 and 7.
Yep. So we did that. Right here. When they're
no, it's like the classwork that you did like on the video. It was day 5.
Oh yeah,
It was Friday.
All right, let me go back a day. Multiplying, dividing. And these.
we're talking about this page.
Oh, the actual
Yeah.
notes part? Okay. All right, so that was yesterday. All right, so day 5. Notes. Okay, here you go. Real quickly, again, I'm just going notes. This was Friday's notes, and a couple guys asked me here, hey, in the notes here, how'd you do that? Because it's probably better for me to do it right in front of your face. Are these the same denominators? No, they're not the same denominators, right? So you cannot just add or done. So you need to kind of get a common denominator. Now, yesterday, we talked about if you can factor the common denominators. These aren't factorable, okay? So you still need a common denominator. They both have x's in them, right? So you always take out the one with the highest exponent. So x and x squared, which one am I going to put in my common denominator?
X squared.
X squared, you always take out the one with the highest one. And again, this is if no factoring is involved, which probably will happen on question 1 tomorrow. They both have y's in it, y squared and a y. What one do we want to put in our common denominator? Y squared, the one with the highest one. All right, we're still going to play the same game as we did yesterday. First, look at this denominator, xy squared, but you got to make it look like your common denominator. So what do I still need to multiply this denominator by to get it to make it look like x squared, y squared? And x, right? Because that's what it's missing. So that's what you multiply the top by. And you end up with x squared minus yx, xy, however you're going to put it. All right, look at the next denominator. X squared y. But I have x squared y squared. What does that one still need to get multiplied by to match the common one here? A y, correct. So I multiply the top one by y. Distribute. What do we have? Yx, xy plus y squared. Everyone notice the two middle terms, even though I wrote them backwards, but they're still going to cancel each other out. So you're just left with, or maybe we're not, x squared plus y squared over x squared y squared. I know there's a lot going on there, and some of you may want to try to factor across out, but we're done. Is this difference of two perfect squares? No, because it should have been a minus sign. It's not. And we've talked about this at length. No. It's attached, right? It's attached with the plus sign. So there's no crossing out, no factoring. So we're done there.
Alright.
You always take out the one with the highest. And again, this is if no factoring is involved. All right, no factoring is involved like yesterday. All right, over here, number 8. Notice anything about the two denominators? They are opposites of each other. So if they are opposites, all right, and you're trying to get a common denominator, if they are opposites, take a -1 out of one of them. And I'll show you why. Take this denominator right now and take a -1 out. You get -1, and then what happens now? That 5 becomes, what's the 5 become when I take a -1 out? -5, and the negative c becomes, okay, now watch. Look at these two denominators now. They're the exact same. That's what I love when they're exact same, because when they're exact same, I can just put it in my common one. But what do I still have left over? Oh, I took care of these. These are the exact same. That's what they have in common. The -1. Okay, so if you see their opposites, take out a -1 so they become the same denominator. All right, last question here. Look at this. Everyone take a look. What's c minus 5 missing from the common denominator that I still got to multiply by? -1. So multiply by -1 and you get -3c. Ooh, lucky for us. Look at these denominators. Same thing. So I don't need to multiply by anything. Unlike the last problem, though, I don't think I'm done. Anybody?
Greatest common factor.
Of?
3.
That's, you could. Can I take out a -3 though?
Yeah.
Yeah, I like to take out the negative. So I'm left with c minus 5. What are you left with? Go on. -3 over -1. Left with 3. All right, fellas.
Can you go over number 6?
All right. Same denominators. 6 is 6 or 5. Okay, 6. 6 is kind of similar to what I'm going to give you tomorrow on the quiz. First question. Not the same. What do they? They have a's, right? What's our rule? Take out the one with the highest exponent, which would be?
A squared.
So a squared's got to go. And I still got what number hanging there?
2.
A 2. So that's got to go in there. All right, look at your denominators now. What do I got to multiply a squared by to get 2a squared?
2.
All right. So that's 10. How do I go from 2a to a squared? And I don't think we're doing anything on top. There's no GCF. So we're done there. So. All right, we good? Anything from yesterday's assignment you want me to go over before I start quiz review here? Because I am going to get after it here with quiz review. Because I want to make sure I did all I can for you to be successful tomorrow. And the rest is on you. Adding, subtracting, unlike denominators. Okay, here's what I'm going to do if there's no questions there. Take a look at your Chromebook, please. I listed, and guys, I'm not even joking around with this one. I went question by question and wrote down the topic. So number 1 tomorrow, subtract with unlike denominators. Number 2 tomorrow, when is a fraction undefined? So I want you to look through those topics right now for me and be like, what are you talking about with this one? Can you go further? Can you go a little deeper for me? And then I'll find a problem on your review that corresponds to that topic. All right? Because all I did, I took your quiz, which is right up here. I went, all right, topic number 1, subtract with unlike denominators. 2, undefined. Go ahead and start us off. Where do you want me to start?
Number 7.
Unusual dividing problem?
Yeah.
Okay, here's what I mean. It's probably easier to show you in your packet because I don't think I put one in the review. I put a question. Everyone go to your packet and look at, what did we do dividing there? Go to page 14 for me. Page 14. Page 14. I'm going to give you guys a problem like number 6. It doesn't look like a division problem, but it is. All right, quickly, the rules for division. Do I do anything to the first fraction? Keep it. What's the division change into? Multiplication. And what do you do to the second one after the division? You flip it. Do that first, then do all your factoring. So that's what I mean by an unusual dividing problem. You guys might look at it and be like, what's he talking about? But it's a division problem. Okay, everyone see that on page 14, number 6? Okay. It's a division problem, just without your classic division sign. So that's what I mean. I didn't put any of those in the review. There's division in the review, but not that looks like that. So, but I just wanted to give you a heads up so we don't freak out. Good? Okay, others up here. Other topics you want me to go take a look at. Let's go. 9, which is multiply and divide in the same problem. Did I put that on the review? Did I throw one of those on? I don't think I did, but it's fine. We could still. Here's what I mean with multiply and divide. So you got a fraction times another one, and then I put a divided by another one. All right, you gonna touch those? Gonna touch this one. What's this turning into?
Multiplication.
And what are you doing with the last one? Flipping it. That's all I meant. Okay, so you're gonna see multiply, multiply, then divide. All right, make sure you flip this one, change it to multiplication, and then factor everything you can and cross out. Okay, so that's what I meant by that one. Here we go. Any others? Good. 8, algebraically. Yep, I definitely put one on here. I just saw it. All right, go to your packet right now. Algebraically prove. Let's see. I know I definitely put one on here. Just got to find where it is. Last question, number 10. Okay, I think you're going to have to do this twice for me on the quiz. So this is one where when you see prove the identity, make one side equal the other, right? Work on one side only, and hopefully it comes out to look like the other side. So let's put our line down, right? That's always our first job. Second job, let's decide on what side we're going to work on. What side are we going to work on here? Left. Yeah, you got. We've this unit's never been about multiplying and doing this, right? It's never been about this. Never. It's all been about factoring, adding, subtracting, multiplying, dividing. So let's work on the left side. Can we make it look like the right side? Your first move. GCF. Darn right. Every time you're factoring tomorrow, your first thought is take out a GCF. I can definitely take out an x to the 4th. How about that 12 and 75?
3.
Biggest number you want, right? Is 3 the biggest? I think so, right? I think 3 is the biggest. I don't think we're going to find anything bigger. So 3 is the biggest. Yep. All right, what are you left with now when I divide? Divide everything by 3 and x to the 4th. 12 over 3 gives you a 4. X to the 4th minus
25.
20. And stop me if you don't know where these numbers are coming from. 25, and that's it, right? Because I took the x to the 4th out. Clearly doesn't look like the right side. Clearly. So you know you got to keep going. All right. Well, where do I keep going then? 4. X to the even number. 25. What did I just list out? All perfect squares. And it's minus. 4x to the 4th. 2x and 2x. What do you know about the signs when you do this method? Opposites. And 25. There it is.
It's 2x squared.
2x squared. Thank you. One job. Okay. So you'll have to do algebraically prove, draw your line down, start working on one side. And again, I'm going to figure it out, guys. You know, if all of a sudden it looks like a good first step and then there's like just this garbage here and then all of a sudden magically the other side comes out. Okay, I'm going to know. So, all right, and no, I'm not going to give you credit for trying. Number 6 on here?
Yeah.
All right, let's take a look at 6. This is all request day here. All right, it's a division problem. We've talked about this already. I keep the first fraction the same. I'm not even going to sniff factoring yet. I just want to rewrite everything. What's the division change into? Multiplication, and usually I flip the next one, but is there anything to flip? Yeah, there is. This bad boy's over what? 1, so flip it. 1 over b squared minus 6b plus 8. Flip it. All right, now that you've done your multiply and flipping it, now let's factor. What's your factoring game look like? This should be an easy one. GCF the top. 3b minus 4. Done. Anything to the bottom left? Nope. B plus 4 times 1 over. All right, here you go. I know some of you group this, and that's fine. I'm just saving time and not grouping it because what's the a value out in front? A 1, so I don't have to group that. I can do multiply to 8, add to negative 6. Negative 4, negative 2. And now you look to cross out top and a bottom. Anything in common up there? Negative 4?
B minus 4.
The whole thing, right? B minus 4, B minus 4, and I think that's it. What are you left with on top now?
3.
And on the bottom, I'm left with 2 B plus 4 and B minus 2. All right. So there's a nice little division problem. Where you at?
Can you go over number 2?
2, everyone. Let's look at 2 now. Yep. This is similar to what you're going to see first question mode, but I think it's subtraction instead of addition. All right. Same thing, though. All right. Same denominators.
No.
Are they the same denominator? Because I'm adding, so I got to have same. No, they're not. And oh, my, geez. It's not this. Cut this crap here tomorrow. Oh, it's 4b squared and 7a because you're just combining. No, you have to have like denominators. You guys just clearly told me I don't. They both have b's in it, so I take out the one with the highest exponent, which would be b squared's got to go in there. What am I still forgetting? Okay, there's your common denominator. Now it's a matter of what you got to multiply each of them by. So b to 3b squared. Definitely got to multiply by 3. And I know you need to go from b to b squared. So not only a 3, but 3b. What's that turn into when I multiply? 15. And either BA or AB, whatever floats your boat. Find your lost remote. And then what do you notice about the second fraction's denominator? So good for you. All right, I don't have to touch the numerator. Anything else?
That's it.
Sure.
Greatest common factor.
Yeah, what do you see in both sides here? Can't take a 2 out. It won't go into 15, but I could take out.
A.
Yep. Take out an A. Simplify it if you can. What's left? 15b and 2. Anything else there, kids?
EB? No. Oh, no, it's going to that plus. It's that plus. No, do it.
We're all good? Yeah, you're right. There's nothing to do here. There's nothing else left. Nothing else left.
For 7, would you just rearrange the top part?
I would before you start, yeah. Yep, rearrange it and then probably take a -1 out before you start. Yep, definitely. Yep. What's up back there, Leah? Number 4 on here, find the difference. Yep. What am I doing in these two fractions, Leah? Well, no. I don't want to factor just yet. What am I doing? What am I doing in these two here? What's in the middle of them? So you need the same denominator, right? That's my point. You need the same denominator here. This is what we did yesterday. And Leah, you notice what can you do with that first denominator? Factor it, yeah, just like we did yesterday, right? If you notice you're adding and subtracting, and you can factor one of the denominators, factor it. All right, looking for somebody here. Oh, all right. Good. If you can factor it, factor it. All right, how about a common denominator? So what do the denominators have in common? Okay, that's got to go in, like we said yesterday, got to go in once. Nothing else in common, but they do have a leftover in there. X plus 4, yeah. All right, so there's your common denominator. Good job, group. Let's look at this first fraction. Oh, do we have to do anything?
No.
It's the same, right? Same denominators. Everyone agree? So I'm just going to write the numerator. There's nothing to multiply by if the denominators match. Oh, they do not over here. X minus 6, what's it missing that I still got to multiply by? X plus 4. How many of you are going to have some self-respect here?
All right.
That's right.
Negative.
But you're not going to distribute an X. You're going to have self-respect and distribute
Negative.
negative X. Got to distribute negative X, right? Watch when your subtraction. That's going to come into play. I guarantee it. I'm telling you, it's going to come into play tomorrow. You're going to have to distribute a negative number. All right, keep going with me. What do you get when you distribute a negative X now?
Negative x squared.
Minus X squared and negative
4.
4. 4. 4. All right, we're getting there. Anybody combine some like terms on top? You guys freaked me out when we did this last week. 2x squared minus x squared. Oh boy, it's just not 2. If I throw 2x squareds in front of you, and I'm like, oh, I'm going to take one away. How many do you now have?
X squared.
And x squared left. What do I got there? 8x minus 4x
Plus 4x.
plus 4x plus 5. Anything?
Factor.
Into
X
what?
Plus 5. X plus 4x plus 5. No.
X plus 4, X plus 4.
I just have to add this one.
Then you add to 5. Plus 5 is 4. 4 times 1 is 4. 4 plus 1 is 5.
You can't.
Thank you, Max.
Exactly.
Why?
Because you have to.
Two numbers that multiply to 5 and add to 4.
Oh, it's
Bro.
Always multiply
Bro,
to the
Minus
C
that
value.
one.
Take them all off. Bro.
I'm trying to confuse
Just
you.
erase their shit.
Not factorable. Not factorable.
Not,
I'm negative.
not laughing about Alex is not laughing about me.
Not
I
factorable.
did bad, so you
just
could do
didn't
good.
take it.
I did bad, so you could do good. Don't worry about it.
Wait again, it'll happen. Okay.
All right, we're good there.
Wait, multiply.
I'm going to go to number 1, actually. Nobody's been asking it, but I'm nervous about it because it's got a vocabulary term in there we haven't talked about since last week. And it will be on the test. Yeah, it'll be on the quiz tomorrow. So number 1, what values was it undefined? Again, what's undefined for us? When the
X is 0.
where though? I got a couple X's here.
The final answer.
Are we worried about the top or the bottom with undefined? The denominator. Good. When denominator equals 0, don't even sniff the numerator. All right, don't even sniff it. Take your denominator, and we got to figure out what numbers can I plug in for x so this whole thing equals 0. What do you want to factor it into? Because always factoring's involved.
8 and 4.
Okay. And this is where you just got to take it that one more step and tell me what x has to be equal to.
-8, -4.
So x equals -8. That could make it equal to 0 if I plugged it in, or -4. So you get two answers out. Okay, two answers. I don't know if you guys remember my trick either. What was the highest exponent up here?
8.
2.
8.
Sorry, never mind. Wrong.
What was the highest exponent?
2.
So that's how many answers you should get. Okay, for undefined. Anything else on the topics? Because I'm going to let you work on your own. Anything else on the topics you want to look at? You got a group tomorrow. We just talked about undefined. 37 points. It's coming strong.
37 point. Wait, how many problems? 10.
10, yeah.
Quarters.
According to my calculations,
Yeah, look.
3.7.
Okay.
Good calculation.
Nothing else?
Let's start it out.
Okay, since you have your Chromebooks open, here you go. Go to the homework answers while you're there, please. Let's go. Open up the homework answers. Unit 1 homework answers, and then open up the review for quiz answers. So you have them, and all the work is there too. I just didn't post answers. All my work is there. It's the first one, Unit 1 review quiz answers. Okay, make use of this time here. Okay, if you want to work with other people, that's fine. And hey, look, if you don't want to do it at all, hey, that's fine too. You guys know how I roll. I'm not going to hold your hand. You're seniors. But you got to see if this is the right spot for you or not.
It's not student.
Okay, when I'm asking for when a fraction is undefined, I want to know what can I plug in the bottom for x that makes that whole thing 0. So let's say if I said the answer was 1, that means I plug in 1 squared plus 12 times 1 plus 32, and I'm going to get 0 back. But that doesn't happen. There's only certain numbers out there that if I plugged in, I'm going to get 0 here. I don't care. I'm not even looking up here. I'm just worried about what do I plug in for x here that gives me 0. That's going to get 0 altogether. So I took this, set it equal to 0, factored it. Okay? And then I set, and where do we go here so quick? I did x plus 8 equals 0, subtracted 8 on both sides. And that's how that
Just
works.
the opposite.
Correct, yeah.
Okay.
Yep. And then now if you take -8, square it, plus 12 times -8, plus 32, guaranteed you're going to get 0.
Okay.
And same thing if you plugged in a -4 there.
And then whatever that number is.
Should be the number of answers you should have,
Okay.
correct.
The final answer is just.
The two x values, correct.
Thank you.
Yes.
You can get your questions out now. I will be after today.